per process. All right, well, so here we go. So we are in section 2. All right, so on this one, there we go. We want to figure out, so they're going to ask us a bunch of questions. What questions are they going to ask us? They're going to say, is f of 8, find f of 8, find f of negative 6. Okay, so here we go. So number 1, find f of 8 for starters. So I'll go back to the graph real quick. On the graph, they want us to figure out where is f of 8? What is f of 8? So the purpose of this section, it's just reading the graph. This section will actually be, at least the beginning part, the first maybe 6, 7, 8 questions. There's no calculation to do. There's nothing to work out, add, subtract, multiply, divide. It's just the answers are sitting right on the graph. It's just you got to speak their language. It's all about, speaking the language of graph and function. So what's to the language? Well, really only one main thing. Well, I guess two.
What x values are 8.
X is in. What comes out is y. That's the main thing. And they made that, by the way, by common agreement. There's not like a logical reason for that. The math science world just agreed. They just said, hey, when we have functions and we want to put their pictures on the graphs, we're just going to make whatever we plug in on the x-axis, and whenever it equals, whatever comes out of the toaster goes on the y-axis. That was just by common agreement.
After all, math isn't real.
Right. It's all made up to show things that are real. All right, so x is 8. So basically what that means is when they ask me f of 8, you just have to say, okay, they want me to find the point that has an x value of 8.
So there's only one.
There's only this one, huh? And they want the y. They want you to give them the y that's going with that. So just be 6. We're done with that one. It's as easy as that. You just read it off the graph. And then the next one they ask is f of negative 6. And they say, okay, got that one. Now tell us what is f of negative 6. So to find that, again, what you do is they're saying, so the main thing is, x is what's plugged into a function. So you plug in negative 6 for x. What's the y value that goes with that? Well, it's right here, huh? 0. We good? Just read it off the graph. What's plugged in is x, what comes out is y. Just read it right off the graph. And then next, they say, is f of 18 positive or negative? So question B, I'll just kind of scribble it down here. F of 18 positive or negative? Now, they don't mean the 18. They mean, does this equal a positive or negative? So if x is 18, so again, what's plugged in is x. What it equals, what comes out, is y. So when you plug in x is 18, now I don't see that listed. It's not listed as a separate point, but can we find out where it sits? About?
Why is it going to be negative?
Yeah, this is 16 here. This would be 18 here. This is 20, 22. So 18 be something there, right? 18 comma something negative. I don't know exactly what. I don't need to. They're just asking me positive or negative. That good there? So when x is 18, the x value of 18 goes with a y value that is negative. So the whole key to graph function reading is what's plugged in is x, what comes out is y. Next question, how often does x equals 5 intersect the graph? So maybe I'll do a fresh one here. Yeah, So now they're saying, part C, x equals 5 intersects how often? X equals 5 intersects the graph. How often? Now, x equals 5, what is that? Well, here's the x-axis. This is 2, 4, 6. So 5 would be about right here. So it's this line, isn't it? It's the line that hits x equals 5. How many times does that line intersect the graph? Well, there's one time right there, huh?
Otherwise, it wouldn't be a function.
One time, right. Good point. Kind of a silly question.
Yeah.
Now, sometimes they'll also ask for a horizontal line, though.
Oh, okay.
So that'll be more tricky. They'll say, how many times? Yeah, what if they asked, because you get different versions, randomizes it for everybody. What if they said, how many times does y equals 6? Now they're giving me a y instead of, because Renee's point is a good one. If they do x, it's a function one time. You don't even need to look. I could blindfold that answer. But what if they asked me for a y?
Yeah, it would be twice.
Because it would go boom and boom. A y hitting the y-axis at 6, up 6, right? 4, 2, 4, 6, 8. Right? So hitting the y value, it'd be 2 2 times
But that's why f of x equals
if they ask
y
that.
is because y is not a function.
What's that?
F of x equals y because y is not a function, right?
No, this function is a function, and y equals f of x. It's all good. So it's not 1-to-1. We'll get into that more later. Yeah. But anyway, so they might ask that version of the question for you. So that'd be 2 times, huh? All right. So let's see. Let's have for what values of x does f of x equal 6? Yeah. Here, let me get a fresh one again. F of x equals 6. Okay. So part D or whatever. What x's does f of x equal 6? Oh, that's what we just did, huh?
That's pretty much y, right?
Yeah, exactly.
Right.
That's the key to reading that. Is that making sense for everybody? This is the y value of 6, isn't it? Because again, what's in here is x, what comes out is y. So they're basically saying, hey, look at the points there. Where do you see y values of 6?
0, 6.
Here.
6.
Yeah, those two. Those two have y values. So what are the x values that go with those?
0.
0 and 8. 0 and 8.
Can you show the question on my head?
Yeah, here's exactly the question. For what values of x does f of x equal 6? So yeah, so what goes in is x, what comes out is y. And the answers are 0 and 8 on that graph. That making sense? For what values of x does f of x equal 6? So what are the x values that make y 6? So we look at that graph, we go y6, the x values are 0 and 8. Their final 2 questions, E and F, are about domain and range. They're going to, part E is going to say, what's the domain? And F, what's the range? So how do you look at a picture, a graph, and find domain and range? Do you remember?
Negative infinity, positive infinity.
Well, notice there's a solid dot here, not an arrow. And there's a dot here, not an arrow.
So negative 12.
Yeah, so it stops there and it stops here. Sometimes they put arrows, so that would be infinity, infinity, negative infinity, positive infinity. And sometimes they put dots, so it stops. Yeah, so the domain, remember, domain is the width coverage. Range is up and down, domain is sideways.
Negative 12 to 22.
Left edge, right edge, yeah. So it'd be bracket, negative 22, no, negative 12 to 22.
Bracket.
Yeah, because bracket, because it's solid dot on each end, it hits solid on both those, doesn't it? Did you guys make it through all those? Oh no, we didn't have that yet. Never mind. Thinking something else that's coming soon. All right. Good to there. Now the range. Last thing is the range. Let's do that. So the range.
Is
Negative 6
6
to
to 8.
8.
Yeah, bottom to top. Bottom to top. So the range would be the bottom is negative 6.
But they're not solid dots. Well,
Yeah, this is the bottom right here. Right, this dot is the bottom dot. And this dot is the highest dot.
So they're solid.
So negative, but negative 6. Put the y values down because range is y values. So y value negative 6 to y value 8. Negative 6 to 8 like that. That makes sense? So we're going lowest y height to highest y height. Negative 6 to 8. So there it is. There's all the questions about that one. All right. So number 2. They're asking, first off, they're saying, determine whether it's a function. Read up here. Determine whether this is a function by using the vertical line test. Do you remember that from your algebra days? Yeah, pencil, however you want to do it. Straight up and down, a vertical line. If a vertical line hits 2 points, then it's
Not a function.
not a function. Yeah, so that's why this one's no. Vertical line test. If a vertical line hits 2 points,
On the same line.
then not a function. Now, how does that fit with the function rule we learned, what was it, 2 days ago, I think? So something's a function. Every x, remember that one? Every x has
Only one y.
only one y. Is that how's the vertical line test really saying that same thing?
It's because they have two X's, or the X have two Y's.
Yeah, these two dots would be at the same X. So that looks like over 2. So this would be over 2 up, I don't know, maybe 5, and over 2 down 5. That would be the same X going with two different Y's. You see how a vertical line hits 2 points means the same X going with two Y's. It's, you know, these are really saying the same thing graphically and otherwise. So yeah, so there we go. And so that's all we need to do on that one. It's just not a function. So you don't even have to answer B and C. That's great. When it's not a function, you're done. So that was just not a function. Next question.
Y's can have,
Yeah, so vertical line, every vertical line hits only 1 point, huh?
yeah. So Y's can have multiple X's, but
Right. So every X must have only one Y. So that one's a function. So when it's a function, then they want to know the domain and the range and everything. So you can do that. Domain is, you know, negative pi to positive pi, left edge, right edge. The range, you can see the answer right there. -1, right, that's the lowest. The highest, there's the range. -1 to +1. That good? Okay, now they're going to ask me for the intercepts. If you can see down here.
0, 0.
Yeah, there's all the answers for the intercepts. It's this point, this point, and that point. Those are the intercept points. Yeah, what is the coordinates of this point? -pi 0.
so it's the intercepts of the X-axis.
0, 0. Yeah, intercept. Oh, yeah, sorry, they're asking, well, any intercepts,
Oh, okay.
because that middle one is both an X and Y, right? So anywhere it hits any grid lines, but we don't have any that are only Y intercepts on this graph. There's nothing hitting like up here or
So
something.
if like the hump went onto one, we would say that that's an intercept as well.
Yeah, that's right. Yeah, any place it hits either grid line. So those are all the intercept points. Just want you to list them all with commas, any order with commas between them. Is that good there?
That's a sine curve with a phase shift.
It's been flipped upside down.
Oh.
Is what it is. Yeah, we'll do those the last couple weeks. All right. Yeah, if you remember from trig, that's an upside down sine curve. Remember, because normally sine goes up first. That sine curve's been flipped upside down. That would be negative sine x is what that is.
Well, if it was just with a phase shift, it'd be...
Oh, that would do it too.
Yeah, that's what I was saying.
Yep. There's another way to do it. It's also sine of x. What would that be? It's been moved left, so plus pi. Yeah, those are two ways to say the same thing.
range is 2 pi for...
Does this graph have symmetry? Now, do you know? Have we talked? I can't remember. I forget. Have we talked about symmetry yet? Whether the graph has symmetry? Let's do that. So if we have this graph like that. So this one. Well, let me go through the various types. So let me do this type here. This type of graph right here would have y-axis symmetry. Because you see how the y-axis goes right down the middle of it? Spears it right down the middle? Whereas this graph that we have has origin symmetry. Why origin symmetry? Because any point on the graph, if you go straight to the origin and shoot through the other side, you have the same dot on the other side. Let me slow down for a minute. Are you tracking? So we're talking about different kinds of symmetry on graphs. So this one is y-axis symmetry because the graph is the same to the right and the left of the y-axis. The y-axis is like a mirror, right? It's identical to the right and the left of the y-axis. This one up here, the mirror is through the origin. So this dot is mirrored over to here through the origin. And every dot is. So if you take this dot here and you go right through the origin, you're going to same distance other side, it'll have a companion dot. So it's mirrored through the origin. We call that origin symmetry. There is one other kind of symmetry that would be like this. What kind of symmetry is that? Yeah, because that's the x-axis, huh? So that's x-axis symmetry. It's a parabola sideways. That one we're not going to see because that one's not a function because it fails the vertical line test. but it does have x-axis symmetry, so that's the other kind we're not going to see. So we're going to see the origin symmetry kind and the y-axis symmetry. Now, the origin symmetry is a little hard to spot. I mean, the y-axis is pretty obvious, identical right and left to the y-axis. X-axis pretty good, identical right above and below the x-axis. But the origin, that can be kind of a little bit weird. So one thing that I do that helps is the other way to think of origin symmetry is it's 180 degree, let me match the color up here, 180 degree rotation symmetry. In other words, if you flip it halfway over, it looks the same. Half a flip, 180 degrees. So let me show that. Oh, there's, I wrote it here. So down on the, what is ours? Ours is, so anyway, so here we go. So say we start with this one. Okay, so I've got a graph like that. I'm going to turn this halfway over, turn it upside down, 180 degrees, and it's going to look the same. It's going to look like I did nothing when I'm done. So you ready? You see the way? See it's down on the right, up on the left, huh? When I flip it over, it's still going to be up on the left and down on the right. Right?
Oh, magic.
Dun-dun-dun. Right. So my point is that's an easier way to spot origin symmetry. Easier for me anyway. I have trouble always being sure when the origin thing. I just think, flip it over. Oh yeah, okay. So that's an easy way to spot origin symmetry. It's just upside down. It looks the same. Okay. So with that in mind, let's go back to this question. What does this graph have? Origin symmetry. Origin symmetry. Let's go to another one. So is that one, is number 4 a function? No. Boom, not a function, not a function. Next question. Those are our favorite ones.
Yeah.
It's just no, next question. Nothing, no other. No more questions, please. Okay, so number 5. So is that one a function first off? Yeah, every vertical line only hits 1 point, huh? Every straight, perfect vertical line will only hit 1 point. So yes, it's a function. See all the answers there. What's the domain? You see the answer. Would you have been able to come up with that? Do you see the domain?
Yeah.
Domain is the width, huh? The sideways, like how far left, how far right. So see how this graph goes up and left forever, negative infinity, and it goes right and there, so it goes to 0, huh? See how it's taking a dive at 0? That's actually, what does it mean when you have a line that you get close? See how it's getting closer to that line forever?
It's always
Yeah, it's an asymptote line, really. Now later we'll use that word and we'll show them dotted lines and we'll find them. We'll calculate them. We'll even calculate them on hyperbolas. We'll go crazy with that later. But for now, they're not showing it. But it's really there. It's taking a dive right there. Yeah, it gets closer to that forever without actually touching that line. So that's why for the domain it would be a parenthesis next to the 0, not a bracket, because it never really hits the 0. That's why they put a parenthesis. And then the range, the up down, that's just negative infinity, positive infinity, right? It goes down forever, goes up and left forever, so up forever, negative infinity, positive infinity. Intercepts, here's the intercept. Maybe you can tell anymore. I've scribbled it all around. But there's the only place it hits any of the grid lines, minus 1, 0. Last question. Is it origin symmetry or y-axis or x-axis?
It's not symmetrical.
None. No symmetry. Good? So these, I think you can move through these fairly fast. Okay. So number 6. I think you can do all the domain or range and all that stuff. Let's just jump to the symmetry question. Does that one have symmetry?
Y-axis symmetry.
Yeah, the y-axis splits. It's identical to the right and the left of the y-axis, isn't it?
But if you rotate it 180 degrees, what would be upside down?
Yeah, if you did 180, it wouldn't look the same.
No.
That's the origins. That's the origins. If you turned it upside down, it would look like you turned it upside down. It wouldn't look the same as it did before, right? This one, remember my magic trick, looked the same, right? So that one doesn't have origin symmetry. That one has y-axis symmetry. Okay, would you be okay with the range there? See the range is negative infinity to 5, the up and down, right? Because it stops at a height of 5. This y value 5, and it goes down to negative infinity. So it's negative infinity, but the 5 is a bracket because you hit the height of 5 right on.
It's a solid dot.
Solid dot up there, yeah. Solid graph. We good? Does that make sense for the range? I think that's the only hard part of that one. All right, I'm going to move on if you're okay. Let me know if I'm going too fast. I'm always trying to move fast. I feel like I need to apologize. A lot of material. All right, so I'm just going to jump to the hard parts if I can. Just do the hard parts would be the most helpful, I think. But let me know if you want to talk more about it. Does that one have any symmetry?
Yeah.
Well, it's not quite in the middle, huh? Remember, it's got to be the y. If they just had moved it over, right, then it would be, remember, you got to be like if you're doing, it's almost got y-axis, huh? But it's not really. The y-axis isn't going through the middle of it. It has to be identical to the right and the left of the y-axis. If they would just move it over, it would have y-axis. But as it is, no symmetry on that. Question?
For the domain on that one, since we don't see it straightening out.
No, yeah, good question. Good question, Rebecca, yeah. So Rebecca's question is, what about the domain? Like, how far left, how far right? It kind of looks like it's going straight up. It's not, though. Yeah, it's a parabola. It's actually going up and right forever. It will keep going right forever. Yeah, I know it's hard to tell when they don't put asymptotes. You're like, well, how do I know? Is it going straight up there? It's not. You just, yeah, they'd have to make it more obvious than that to make it. Yeah, so domain would be negative infinity, positive, which is somewhere
And the
here.
range is cut off when there's a solid dot.
Yeah, the range, the bottom of the range would be -9. Yeah, -9 to infinity. Good question. All right, I'll move on with that. And ready to go for calculus is kind of how it's all come about over the years. So we have every last topic in here. So, all right, so is the point 2, 8 on the graph of the function? So let me make it a little bigger. Can you see that function there? F of x is 3x squared minus... no, I'm just going to just plug right in there. How do you know if a point is on a graph? Yeah, I'm not going to bother to actually graph it. I guess you could, but I don't want to bother. How could I find out if a point's on a graph when I've never seen the picture?
Plug it in for the value.
Just plug it in, huh? It's got to make it true. That's all they're saying. Plug in x to be 2 and see if it comes out 8. Remember, because the y value is what comes out. They're just testing if you're still aware of that. What you plug in is x. What comes out to equal is y. So plug in 2. Find out what f of 2 is. It should come out 8. So I plugged in 2. So 12 minus 2 minus 2. Sure enough, it's 8. So that's why the answer is yes. 2, 8 would be on the graph, because when you plug in 2, you do get 8. So that means if we were to look at the picture, the point over 2 up 8 would have to be on the graph, huh? Makes the equation true. Next question. If x is -1, what is f? You could do that, just plug it in. What I really want to get to is question C. That's one worth our time. If f of x is -2, so let me just write that out bigger for you. So f of x equals, what was our function? 3x squared minus x minus 2.
So it's saying if y is -2.
Yeah, that's question number 8. And they're saying, yeah, if f of x is -2, what is x? F of x is -2. What is x? Yeah, let me let you give that a try. A good thing to have on that exam, you get a 3x5 card, write anything you want front and back, is this, because solving x squared equations comes up a lot. All right, first step, get a 0. Let's do it. So I'm going to add 2 to both sides. Boom, that'll give me 0. So there's step 1. Get a 0. Okay, and now step 2. What do I do in step 2?
X parentheses.
Yeah, good job, good job. Try to factor. So, yeah, this one will factor. Yeah, remember now factoring, there's a couple different ways. There's the 2 parentheses. That would be like if I had a third term here. If I had like a +7 or something, then I would try for the 2 parentheses, right? If you have 3 terms, x squared, x, no x, you try for the 2 parentheses. But really, even for that method, by the way, you should always first ask the question, is there a GCF? That's really always the first question for factoring. So, is there a GCF? Is there something in common? Yeah, they both have an x, huh? Always do that first. Always do that first. Take out the x, x times 3x, x times -1. See how that would go back? That's the same thing. Right? Good so far. So, factor, and then what? Each one equals 0. Remember that? Because the two things times to equal 0, either one could be 0. Rebecca?
When you were talking about factoring last time, you talked about like a way to figure it out. If it wasn't that simple, like that was an X and.
Yeah, right, for the 3 terms.
Yeah.
Yeah, the diamond method where you
I
try to
did not write
factor.
it down, and I couldn't find it.
You can grab me after officers. I can go over one of those with you. We don't have any in this section that's needed, so I don't really want to do it right now. But yeah, grab me. Glad to show you one of those. So all right. So step 1, get a 0 factor. We did set each part to 0 because if 2 things multiply to be 0, either one can be 0. So this one's done. Move this one over. 3x is 1. Divide by 3. 1/3. So 0 and 1/3 are the 2 answers. 0 and 1/3.
I just plugged it into the cloud and got this answer.
Good so far. Now they're going to ask me to give that answer a different way, and I want to make sure I show you about that. So you good so far to there? So they're going to now say, okay, you got your function. Well, what was it? Yeah, f of x. We got the question was f of x equals -2. Find x. We did. X is what? 0 and 1/3. Everybody okay with all that? Got that down. Okay. Then they'll say, this means. So first off, they do want this answer. You type it in. They want that. Then they'll say, this means what points? They want you to also turn it into like x comma y, like ordered points. Do you realize that's 2 ordered points? X is 0, y is -2. And x is 1/3, y again is -2. So they both came from a y -2. X, y, x, y, done. Does that make sense?
Oh, yeah.
Do you see that? Right? They're just again making sure you're crystal clear that function values are y values.
If y
Right? This is a y value. Right? So that's the main deal. Function values, f, g, h, whatever your function is, function values are y values. So that y value goes with each of those x values, so that it also means you can write it that way. Yeah? Well, the first answer they want is this. So let me show you. Let me go back to the answer screen. Yeah. See the answer. First they say, what is x? So they want just the 2 x's. And next they say, using this, list the points. And then they want it that way on the next part. Those are 2 parts to see there. They want just the x, and then they want the points. Is that making sense? So first off, they want the x, and then they want the points. All right. So is there anything else on this question? Domain, yeah. So the rest, yeah. You tell me what would. So for the function, f of x equals, what was it? 3x squared minus x minus 2. 3x squared minus x minus 2. What's the domain? So this is like d, or I think it's d. What's the domain of that thing? Yeah. Remember what we looked for? Domain is looking for trouble spots, like what you can't put in the microwave oven, no metal, right? What can't you put into that function? What are his problems? He's got none. He's got no denominator issues. He's got no square root issues. Remember, those were the 2 issues we looked for and said, hey, no zeros in the denominator, no negatives in the square roots, because that's imaginary. Well, he doesn't have either one of those problems. He doesn't have any denominators. He doesn't have any square roots, so the domain is just anything goes. Remember that? Those are just easy. They don't have any roots or denominators. So domain would be negative infinity, positive infinity. That is x squared. So last question. It's going to say, so again, 3x squared minus x minus 2, right? Yeah. They're going to say, what are the y-intercepts and what are the x-intercepts? So let's start with the x-intercepts. I think that's the harder one. So we talked last time, I think, about finding intercepts. Do you remember how to find intercepts? How do you find like x-intercepts without looking at the picture?
Just plug in
Plug in what?
number.
What number? 0? For what?
No.
Always the opposite letter. Remember, it's always, so if you want to find x-intercepts, make y 0. If you want to find y-intercepts, make x 0. Remember, that's real important that you know that. Comes up a lot. So set y to 0 and solve y. Why do we do that? Maybe again, if I can sink it deep in your mind. Because if you have a function, say, that hits here and hits here, do you see how at an x-intercept, this is an x-intercept, right, hitting the x-axis, that means the x, I don't know, but the y's got to be 0, doesn't it? If you're on the x-axis, your height is 0, isn't it? If you're an x-intercept point for any graph, that means your y value is 0, doesn't it? And if you're here at a y-intercept, that means your x is 0. I don't know what your y is, but your x has got to be 0, doesn't it? You're over 0. So it automatically means the opposite letter is 0 if you're on that grid line. If you're on the x grid line, your y is 0. If you're on the y grid line, your x is 0. It's got to be. So that's what we do. If they ask me for x-intercepts, I make y 0. Okay, so I'm going to take this equation now, and I'm going to make y 0. Where's y?
F of X.
Yeah, there again, making sure that you're 100% clear on that. Function values are y values. So you make that whole side 0, huh? Don't worry about it. You might think, what about the little x there? Whatever. The whole thing is y. The whole f of x or g of x or h of x or whatever. The whole thing is really y, and y is 0. So now we got to solve that. Oh, we do have one of these. Oh, good.
Yeah.
Good, let's do it. Yeah, do you know how to solve that?
I like diamond method.
You could do the diamond, or if you don't like that, you can do the quadratic formula.
Yeah.
Yeah, either way. So,
Take it like it is and throw it into the pond.
yeah, you know, I hesitate because I'm thinking over in my mind whether I show you a cheap little trick, which is sort of mathematically backhanded, but it works in the end, or I show you the formal way. So maybe I'll do both really quick, which I probably don't have time to, and I'll regret later. Maybe, hopefully not. All right, so here would be the straight ahead but harder way. You would look at it and you'd go, okay, what times what is 3x squared?
3x plus 2.
3x and x makes 3x squared, right? I'm just thinking about how it'll FOIL out. And then the back, what times what in the back makes negative 2?
1 and 2.
2 and 2.
1 and 2, I don't have the signs yet. Now, 1 and 2, how are they going to make the middle term? What's in the middle?
Negative 2 positive 1.
Negative 1 there in the middle. So negative 2 positive 1, because negative 2 plus 1 makes negative 1, right? Is that good? Right. It's not good.
No.
Right. It's not good. Samantha, right?
Yeah.
Samantha knows it's not good. I hope you all know. But I found many students think that's good. They think, well, no, Ms. Tarrant, you're supposed to add to be the middle term. And 1 minus 2 is negative 1. You multiply to be the back. They multiply to, what's the problem? It's not that simple when there's a number in the front. It's not that simple. Let's check it. Let's FOIL it. It won't work. 3x squared minus 6x, boom, boom, plus 1x. See, the middle is minus 5x. No, what happened? Well, it's because you have a number. Remember, the ones with a number in the front are more complex. The interaction wasn't just 2 and 1, it's 6 and 1. That's kind of hard. You got to think all that out. So now you got to adjust that and make that work. How do you do that? You go, oh, the 2 and the 1, they're messed up. What am I going to do with them? Put the 2 here and the 1 there. Switch the order. The order matters. Now try it. What signs do you need? I don't know. Maybe put plus, put minus. Let's try it. You just kind of got to guess and give it a go. Let's try it. So the 3x is going to go boom, boom. What do you get? 3x squared minus 3x and boom, boom. Plus 2x minus 2. Is that right?
Yes.
That is. That's minus 1x in the middle. That's the right factorization. So you just got to try stuff. You just got to write it and FOIL it, write it and FOIL it, write it and FOIL it. The more you do that, you'll be able to do it in your head. And you'll be able to kind of see it, and you'll be quicker. It's slow and painful at first, but just keep doing it, you'll get quicker. Now, having said all that, there is a gimmicky trick. I don't know, I've resisted it for 20 years of teaching math. I finally broke down. I'm teaching an algebra class, and I was running out of time, and I just said, all right, here's this gimmick. I think they liked it. It's quick. All right, so I'll show you this gimmick real quick. There's a gimmick called slide and divide. I don't know if you ever heard of it. Where you have a number in the front, you can just slide it to the back. Now, technically, that's illegal. You can't be sliding numbers around. That's why I say it's backhanded. I mean, that's not really true. This doesn't really equal, so I'm going to slide it to the back, and when it goes back there, it's going to multiply. 3 times 2, 6. This doesn't really equal that. That's not true. But we're gonna do something later and slap it back, and it's all gonna work. It's sort of backhanded, you know, but it works in the end. It's called slide and divide. It's a little trick. It is pretty ingenious little method, but it's not this. So I'm not gonna write equals. It doesn't really equal that. All right, so you slide the number in the front to the back. Then you do the diamond thing. That's where the diamond comes in. So now you do the diamond thing, right? Have you guys seen that before? You're saying what multiplies to be negative 6 adds to be the negative 1 in the middle. Right? What two numbers multiply to be this? It's always add. Now you can just do it straight. You don't have to worry about all the other interaction. It simplifies it. Yeah. 3 and 2, huh? Whoops. 2 and 3, 3 and 2, whatever. Order doesn't matter. But the signs matter. How do you get the signs right? Whatever sign is on the bottom goes on the bigger. That's how I help my algebras. I said bottom bigger, BB, bottom bigger. So whatever sign's on the bottom goes on the bigger number. 3 is the bigger one. So negative, oops, I'm erasing. Negative 3 plus 2 makes negative, well, they add to be negative and they multiply to be negative 6. That's my pair. So you go, okay, I got it then. X plus my pair, right? X plus 2, X minus 3. Well, you sort of got it, except remember we did a trick. So now you got it. That's the slide. You slid this 3 to the back and multiplied it. Now you got to divide that 3 because you really multiplied that 3, didn't you? And that was technically illegal. So now you got to, here's the backhanded part. We're coming in with the backhand now. Now you got to divide by that 3 because you illegally multiplied it. Now divide what? Just the back. Can you divide just the back? Well, not really, not normally, but with this trick, yeah, it'll work. You divide just the back by 3, okay? And then you reduce wherever, we always reduce fractions. This can be reduced, huh?
Yeah.
The x minus 1. Now, what do you do with the other part? Is it just 2/3? No, then you do this slide it back trick. You grab this and slide it back. Any numbers left over in the bottom, you slide back 3x plus 2. See, there's the same answer. We got the other. We never had to think hard thoughts about order and interaction. We just slide it, diamond, divide, and slide it back.
I've never seen you do it, like, someone do it like this. Like, I've always had professors just say, oh, you can put 3.
Yeah, that's more faithful mathematically. It is, and I've always done it that way too. So I feel sort of like I bowed the knee to
You're still gonna get two answers out of this
efficiency
question.
instead of purity. Yeah. Oh yeah, so let's get back to finishing this problem. Yeah. All right, so we're still set equal to 0. You're right. Right, so let me get rid of all this slide and divide. This is on YouTube if you want to watch it. And if that was confusing, I know when you see something new for the first time it's weird. Feel free to watch it later, whichever way. It's all on YouTube. Let me go back to, let's finish this problem up. You're right, we got to get this thing finished.
And
So getting
it's
back
still
here.
asking for the X-Intercepts, right?
It is. All this was for that. So 3x plus 2. And you could have just done the quadratic formula also, by the way.
So much easier.
There's so many ways to do it. All right, get back to here. Now what do? We set each one to 0 separately, don't we? Because if two things times to be 0, either one could be 0. So set that one to 0. Finish this up. Move the 2 over. Negative 2, divide by 3. And move the 1 over 1. So 1 and negative 2/3.
Yeah.
Those are the answers
I got
that the quadratic formula would tell you.
Yeah. Okay.
Yeah, 1 and negative 2/3. Is that good? We found the x-intercepts.
I just did the quadratic formula. It took me 5 seconds.
So how do you find intercepts? How do you find an x-intercept? Make y 0. How do you find a y-intercept? Make x 0. They're also going to ask you for the y-intercepts. Can we do that one just by looking?
Yeah.
Tell me. Y-intercepts, we're going to set what to 0?
Minus 2.
X.
X to 0. So if you come up here and make x 0, what is y going to equal? Minus 2. Done. Right?
Yeah.
That too quick?
And we already know
Fine.
that. because-
Y-intercepts, x is 0. Put an x 0. Y is negative 2. Done. That's the whole question. All right, we did that one thoroughly. And it says f of x equals x plus 6 over x minus 10. And they say, part C says, if f of x was x, okay. F of x equals 2. What is x? Okay. So, can you do that? I'm going to skip all the rest. All the rest of the parts are easy for
So
you.
if y equals 2,
Right, so see if you can solve that.
then we just put it over 1 and cross multiply, right?
Yep.
Okay. That was one of my favorite things.
See if you're comfortable algebraically with doing that.
26.
Yeah, I think 26 is the answer, isn't it? So, yeah, so f of x, notice again, it's not x equals 2, huh? It's f of x is 2, so the 2 goes over there, doesn't it? So 2 equals x plus 6 over x minus 10. Yeah, then how do you solve that for x?
X equals 20.
Remember when you got a whole number on one side, fraction on the other, what do? I want to make sure you're algebraically comfortable. Put over 1, diagonal, diagonal. It's one way. You can just multiply x minus 10 on both sides, same thing. So then you get 2, x minus 10, 1, x plus 6. Distribute, 2x minus 20, 1x plus 6. Got x's on opposite sides. Subtract 1x from both. X minus 20 is 6. Add 20. X is 26. Good? Remember all that from algebra? Solving that kind of thing, cross multiply? All right, there's just a lot of tricky questions in this section. All right, so number 10, 6x squared over x to the 4th plus 9. So number 10, f of x equals, and part C says f of x is 1, what is x? X is 1. Okay, can you do that one?
Do it again?
Yeah.
The one
It's the second part will be a little different though. Yeah, see what you can do on that one. Just doing the part C's, which are the hardest parts. So f of x is 1. So we're going to grab that 1 and put it over here.
Get everything over on one side and set it to 0.
Yep. So we get to there. Good. And so you know what to do, right? Put the 1 over 1, cross multiply, that whole thing. Put this over 1, diagonal, diagonal. We get 1 times x to the 4th plus 9. 1 times 6x squared.
I don't know.
So I get y equals plus minus
Good to
root
there.
3.
Boom, boom. So x to the 4th plus 9 is 6x squared. Everybody good to hear? Pretty normal to hear. Now what? What do we just got 4th powers and kind of weird stuff. What do you do? I want to make sure you're okay algebraically from here. What should we do? Pretty much that same, yeah, I got it on the sideboard too. The x squared strategy. Pretty much, where is it? I don't know. It's gone.
Squared over on the
Somewhere I wrote it. I'm going to have to write it. You can't find it. Looking back forever. Pretty much the x squared. What's the plan? The plan is step 1, get a 0. It's the same kind of thing. Step 2, try to factor. You know, that whole same plan. So whenever you see high powers, x to the 4th, x squared, things like that, that's pretty much what you want to do is get a 0 on one side and then try to factor. So I'm gonna subtract 6x squared from both sides, and I'll get x to the 4th minus 6x squared plus 9 equals 0. Is that good to there? All right, so let me bring it up here. We have x to the 4th minus 6x squared plus 9 is 0. So how do we, does that one factor?
Yeah.
Yeah, x squared and x squared in the front, because those will multiply to be x to the 4th, right? Remember powers that? And then you need 3 and 3. What signs on those?
Negative.
Both negative, yeah, because negative times negative, they'll multiply to b plus 9, and then they'll add in the middle to be the minus 6. So that one's not too bad. That's not the...
You just factor.
Why is that factoring easier? Because there's not a number in the front.
Right.
So that one, the ones with the number in the front, that's when you got to do the slide it to the back and divide, or if you're just really good at foiling it out every time, those are harder. So the ones with the number in the front, those are the harder ones. The ones without the number in the front, you can probably do those just straight like that. Now what do we do from here?
It's going to be equal
Factor out
to
an x.
Each one gets their own 0. So x squared equals, and there's no use in writing the other one's the same thing, right? I don't need to write that twice. How do you solve that for x now?
so plus 3 add
Yeah, plus or move the 3. Move the 3 over and
root 2
root on the house.
plus minus.
Plus minus. When you put a roof on the house, you're going to have to go up and down your ladder. When you put a root on both sides, you're going to do plus or minus. So there's the two answers, plus or minus root 3. Good? Yeah. Rachel, right?
If you were gonna do like the x method for that, would you have to put like the x squared minus the minus 3 instead? Like,
What do you mean by the x method?
I call it the x method, not the standard method. Like where you do an x.
Oh, okay. Yeah.
Because like I
Yeah.
know for the first one you put like 3.
You would multiply to be the back. It's always multiply to be the back, 9, and add to be the middle. The add's always the middle, the multiply's always the back.
It would be -3, -3.
It'd be -3, -3. That's right. They multiply to be, they add to be -6, multiply to be +9.
But when you put it back in, like, to equal 0, right? You would do that still.
Yeah, you still got to do, and you remember because there's x squared in the front, huh? Not just regular x. Yeah, that's right. Exactly. You're right. Good? Is it all good? So that's the hardest part. Okay, let me let you go ahead and copy down that graph. Those graphs, those 2 graphs. Give you a second on that.
So it never touches 0?
So we want to answer their questions on that one. So question A says f plus g of 2. You can already see the answer there. F plus g of 2. What does that mean? Like, what do they want me to do? What that means is, did you know that 2 on the right there? That's a plug-in to. It's not a multiply. Whenever, I know it's confusing. I don't think math did the best job in their way of writing things here. But because a lot of times, normally, we think of parentheses as multiply, huh? But whenever you put parentheses with a number after a function, that's not times, that's not multiply, that's actually plug-in, isn't it? So that 2, well, if I do that, it's going to look like distribution. It's not. It's not distribution. It's not multiplication. It's actually f of 2 and g of 2. Notice I'm not saying f times 2. I'm saying f of 2 and g of 2, meaning 2 plugged in to the toaster. That's why I do the toaster talk, to help people think that way. Plugging into the function. Plugging into the function. So in other words, I want to plug 2, which means what? How do we use a graph when we're plugging in? What goes in is x. What comes out is y. So for the f graph, this is the f graph here, the straight red line. The red line is the f graph. If you put in 2, look for the x value of 2 on the f graph. Right here. What's the y value that goes with it? 6. That means this comes out 6 plus. And now what's the g? Put in the x value. Look for the x value of 2 on the U-shaped g graph.
2, 0.
Right here. Here's the x. Here's the y. The y is 0. Out comes 0. 6 plus 0, 6. That's how they got that answer.
Is that a G next to that too? Like,
Yeah, this right here.
Yeah.
It's the nicest G I've ever written. I'm just kidding. That was sloppy one. Yeah, that's a G. Is that making sense what happened there? So when they go F plus G of 2, they mean plug in 2 to both of them, give us the answers. Well, how do you do that in a graph? When you plug in 2 on the F, it means go to the F graph, find the X value of 2, give us the Y. Then go to the G graph, the blue one, and put in 2 for X, and give us the y that goes with it. Find the point with an x value 2 and give us the y that goes with it. Add those up. Want to try part B? F plus G of 4. So give that a try.
For what you plug in for the y, it comes out x, 2, right? So like you plug that in for y, right? For the g, and that is your...
Okay, we don't plug anything in for y. We're only...
No, I'm talking about like plus the g, because g is supposed to be like... Wait, what?
G's just another function. Yeah, G's just the other function.
I'm sorry, I'm reading like 3 hours of sleep.
All right, so now, let's do part B. So we'll come in there for part B, and we're basically going to do 4 for both the functions. So for part B,
F plus G.
it's going to be f of 4 and g of 4, right? That's what that's saying there. So let's go find, let's put, and those are x, remember, so whatever you plug into any function, that's always x, and what comes out is y. So when you go to the f graph, where's the x value for? It's right here. The y that comes out is also 4. And then for the g graph, when you put in x4, right here, x4 on the g graph, what comes out is -4. And that's why they get 0 for their answer. Is that making sense on how to do that? And the other ones are just, subtract, multiply, divide. It's all the same stuff. Just find the values on the graph. Just find the x and the y that goes with it every time. You okay? You guys don't still look like you're kind of giving it a close look. You want to do one more? You want to do F? Want to jump down and do maybe the hardest one? No, it's the hardest one. Try F. So F divided by G of 4, right?
So we're
We'll
X
do
equals
F here.
4.
It's part F. So it's going to be F of 4 over G of 4, isn't it?
Okay.
So go to the graph, find F of 4.
Which is 4.
Mm-hmm. And find G of 4. See if you can find those. So go to the F graph, find the point with an X value 4. The Y value is what comes out. Right? You plug in X. What comes out is whatever the Y value is. For the G, plug in 4. Here it is. What comes out is negative 4. 4 over negative 4, negative 1. That's how they got that. Good on that? Reading off graphs?
So you're plugging in, like, the eggs, right?
Yeah.
And then you get, it's like, okay, I get where you're getting it on the red part, like
Uh-huh.
the coloration. But, like, why are we using -4 instead of 4 on...
The G value.
Yeah, so for the G, this is the X value. So on the G graph, the blue graph, so it really just matters which graph you're looking at, huh? So for F, I'm looking for my numbers on the red graph.
Right.
For the G, I'm looking on the blue. And what am I looking for? I'm looking for the point that has an X value of 4. Find it, and then give back the answer, whatever the Y is that goes with that one. Does that make sense? The answer is always the Y next to that X. Yeah, the X is where you look, the Y with it is the answer. We're trying to be realistic. So this is number 12 here. And basically what they ask is, they say, what is C of 0? C of 0.
100.
Yeah, so let's take a look. So on this graph, it's kind of an exercise in reading x-axis, y-axis. So notice the x-axis is number of minutes, and the y-axis is cost in dollars. So they're saying find C of 0. So again, that means x. Remember, whatever, they just keep hitting that theme, huh? Whatever you plug in is x. Whatever comes out is the y that goes with that x dot on the graph. Let's go to the graph. Find the point with an x value of 0. Well, that's this dot right here. His x value is 0. His y value is 100. So 100 is the answer. Everybody with me on that? Same thing as before. You find the dot with the x value 0. What it equals, what the answer is, the y value. So, okay, then they're going to ask, what does that mean in the real world? This is like more of a real world kind of thing. This is cell phone cost, is what they're saying. So what does that mean, like real life, about the cell phone and what it costs?
Your base cost is going to be $100.
Yeah, and base is right. And what's another way you could say that? Give me minutes.
At 0 minutes.
0 minutes. Everybody with me on that? That's saying at 0 minutes, the cost is $100, which means like base. That's exactly right. If you don't use the phone at all, it's still $100 for the plan. Make sense?
I would never have that plan.
Is that good on that? So, there's other questions just like that.